is a look into the process of programmers on Team TARDIS. I will be interviewing a teleop programmer and an auto programmer to give you guys two different perspectives. As of now in the season, we are close to 2 weeks away from our first competition, which is on December 21st. So, I decided to talk to two programmers on the team. We will cover the different parts of programming, and we'll also talk about the programmers themselves a tiny bit. Time to bring our guests in, who will give you more insight on this part of robotics. Hello, how are you guys? Can you introduce yourself for the audience?
Oh yeah, so hi everyone, I'm Evan Ting. I am a junior and this is my third year in the team. So I'm from Corning Painted Post High School, of course, and now in the team I'm a programmer and also a specifically Chinese outreach coordinator.
My name is Victor Rusev. I'm a senior from Corning Painted Post High School. This is my fourth and final year on Team TARDIS 5356. I'm primarily the teleop programmer. I have also been a designer and a builder.
Okay, so how has the season been going so far for you guys?
For me, I think this season really has a really interesting game, and to be honest, there's also a lot of challenges that we need to work on. So it has been pretty good, I think. So now our robot is built, and it's for us programmers to program the teleop and auto to make it do what it wants to do.
Generally speaking, this season has been difficult but enjoyable, I would say. Early on we had a big, do we want to do things data driven or do we want to do the physics and theoretical stuff for this year? We're shooting balls into like a little basket type thing. It's been fun. On the design perspective, from what I've heard, it's been a lot of just cranking away. I've been mostly focusing on developing teleop, and it was pretty straightforward. We had our teleop mostly done about a month ago at this point, so we've had a lot of time to just think it through, debug, and now that we have the robot, it's been mainly debugging it, making sure that everything's working properly, and then hopefully we'll quickly pivot over to driver practice.
Okay, how many people are currently working in programming?
As of right now, it is 4 people who are mainly working on programming. That is me on teleop, then Even and another student, Tang, are working on auto, and we have a 4th, Rua, who is working on small demonstration robots as a training type thing, so that she can hopefully get onto competition robots later in the season.
Okay, so how did you guys get into robotics? Where did you start?
So I kind of have a really interesting encounter, is that the word, with the words first robotics. So 4 years ago, I just moved from Shanghai to here, and for high school. So there's one day that I heard there's a Winds of Eagles Girls in Aviation Day. So I went there for STEM related explorations, and I saw TARDIS, and then I originally really liked robotics but didn't have chance to study with it, and then it's really lucky to meet TARDIS, and then TARDIS is I don't know, I just got into the team, and yeah, that's how I meet robotics.
My sister was on the team when I was young in elementary school. There's actually a photo of, I think, 8-year-old me at a TARDIS outreach event somewhere on our drive. So I've always been loosely aware of it. I wasn't entirely sure in 8th grade whether or not I wanted to join, but my mom heavily suggested that I should, and I did wind up doing it. I also had a lot of experience just playing with Legos and stuff, and it seemed like a cool continuation of that. So yeah, that's how I got on.
Yeah, I think we're both like really happy on this decision, right? We really like enjoy the
Oh yeah, absolutely.
journey. Yeah.
It's been worth a lot. Yeah.
Oh yeah.
Okay, so when you joined the team, why did you pick this role? Like, why did you decide to be a programmer? And did you start with it when you first joined, or have you gone like on a journey doing other things?
I bounced around a lot. In the interview that we had, I initially said that I would be a programmer, but the way how it panned out, since we at the time had 4 programmers or 3 or 4 programmers already when I was a freshman, it was a too many cooks in the kitchen type of situation with programming. So I actually did building and a little bit of design first. I think I built and designed the main lifting mechanism for that year. Then the year after, I kept up with designing, getting more into 3D modeling. I wound up making one of the subsystems on a robot that year, and we went to Worlds, so that was pretty cool. Last year, I actually took my first big proper step into programming with making the entire teleop for the robot. Also, a third of the robot, physically speaking, was me. And this year, just because the robot is more interconnected, it was decided that we'd have less designers, and so it's just 2 people working on the entire design. So I've been focusing more so on programming and really getting a high level of automation for our teleop this year. So it's kind of just fell into place, but it was always planned at some point that I would program type thing.
Yeah. So I started up with like myself preferring programming, cause at the time I am like actually like more interested into programming, and also I'm like a little like afraid of like doing building stuff because I don't know the English name for many of the tools. That was kind of an excuse, but that is my real thought at the time. So yeah. And I just like continued on the path of programming, and I found myself liking it. So I just like decided on going along that path. But as time goes on, I am like I think I am having more and more interest into designing and building too, because I think they're really important skills in the engineering process, and I really want to like know how like the process works. Mm-hmm. Yep.
Okay, so what are your guys' like favorite parts of like programming on the team?
Can you explain this question again?
Like what do you enjoy doing, kind of like with programming?
I enjoy when my code works.
Yes.
When my code works and I'm driving the robot around to make sure that it works, I'm having a good time. When something doesn't work and I have to hit my head against the wall for half an hour to figure it out, then I'm having a little less fun. But then it works and I'm having fun again. So that is the cycle of programming.
Yeah.
Also, when you, I guess, come up with a new system in your code while you're like getting through it before debug, that's pretty enjoyable. Like, ooh, I feel good about myself. I'm doing this new thing. And then you notice all the bugs with it the first time you try to run it, and then it's back to the 30 minutes to 3 hours of debug.
Oh my god.
Do you feel that like debugging is the biggest challenge with your role on the team?
Sometimes.
Yeah.
It's unclear sometimes what is and isn't going wrong, and you have to sit down and just read your code and think through it. And I'm not sure if it's really challenging, more so than it is just tedious and arduous and not fun. But
yeah,
it's
seeing
part of
it
it.
work is always enjoyable, and also more specifically, even if you see there's errors, but if you know how to solve it, that'll be enjoyable, unless it's not working again. But yeah, I totally agree with what Victor says.
Okay, what is your guys' debugging process?
I generally go with... Okay, the first thing that you do when you're debugging is you have your finished, untested code and you try and running it. And inevitably, the robot will refuse to run your code, and it'll come up with a little message that has like 150 things that you have to shift through, but normally somewhere within the first 3 lines of that message will be what file and what line of that file is throwing an error. Then you just go through there and try to correct stuff like that. So there's that kind of debugging, which isn't too difficult because it literally tells you where the error is and you can go and fix it. The other debugging is when it does run, but it's not behaving how you want it to, and then you have to sit. Then from there, what I do is I just sit down and I try to read through all of my code and see, okay, I have to think like the robot. I have to think, okay, this value is set to that, this value is set to that. Therefore, this thing is active. Should I do that? Yes or no? Is this other thing also true at the same time? Do those conflict? Stuff like that. And that can be hard to do. When it gets very complicated, like an issue that we had last year with our lift, eventually I might pull out a binary search tree. That's a fancy term that essentially says, okay, it's either this half or this half of the code that has something wrong with it. So you remove one half, test if it does or doesn't work, then you know if it was or wasn't that half. Then you take the half that you knew it was, and you cut that in half again, and you just keep going down until you get to the one piece of code or the couple pieces of code that are misbehaving. Mm-hmm. That's how I debug teleop. I'm not sure how auto is, but
in auto, okay, that's a long time ago. I don't even remember. General process is kind of the same. You just like if an error jumps up, you it'll give you like a rough guideline of like what it think is wrong and like where these errors might be. But normally you go to there and then if you find the error, you correct it and things will work. But more cases, it won't be at the place that you find it guides you to. So we, as Victor just said, I think the logic is like roughly the same. You just like read through it, see like if anywhere has a error on the sequences or something, and then you just correct it.
Okay, before I ask anything else, what programming software do you guys use, like for coding and stuff?
we use Java as our programming language, and we use Android Studio as our programming environment. Mm-hmm. And we also use GitHub as an online backup, and also as a way so that we can collaborate from multiple devices. Mm-hmm. We use Java just because that has been historical for first. A lot of teams have used it for a long time, and there's a lot of resources for it. So we kind of default to that. I know there are a couple things that might use Python, but we don't use them. Like Limelight uses Python, right?
Yeah. I'm pretty sure that's why we don't use that.
That's why we don't use Limelight, because it uses a different language. And we use Android Studio just because it is fairly compatible with the robot. It has a whole user interface for detecting what robot you're connected to. That way you can push.
Yes.
It also connects to GitHub pretty easily. Mm-hmm. There isn't an exact reason why we couldn't use something like Visual Studio Code or just Visual Studio instead, but those are what we use.
Yep.
Okay, what is some advice you would give to someone who is interested in programming on like an NPC team?
Wait, I need to think.
I would say if you have something like Discord, there are global channels for robotics, and those include programming resources. That way you can connect to other people who are doing it. It's get help, I guess, is the best way.
Yeah.
Find resources. There's stuff like FTC Lib and WPI Lib that'll have extra stuff for like explaining how things work. So whatever external resources for help that you can find, I would definitely recommend using. Another one, if you are using Android Studio, Control B is your best friend.
Oh, yeah.
Because that lets you, that will take you to the definition of a...
It lets you trace where that is used.
It lets you trace where something is used, and also lets you trace something back to its original definition.
Yes.
So that you can just look at it, source code directly, and understand how things that you may be taking from somewhere else actually work.
Yeah. So, speaking of students that are interested in joining an FTC team and like specifically wanting to like do programming, my suggestion might be like to be open to everything, like be open to build and also like design and programming, because you kind of need to know a bit of everything when you start programming, because you have to know like how they design the robot to make it work. So that's...
You need to understand how the robot that you're being handed is intended to work.
Yes, that's
that
true.
way you program accordingly. And that could be either that you had hands in designing it, or you are maintaining frequent communication with the people who did.
And this also like leads to communication, which I want to say communication is so important. That we actually met like a challenge in communication last year, because like people in the within the programming team and people across programming and designing team were not like communicating effectively, so which led to like some like challenges.
There were moments where some physical aspect of the robot would be changed, which would impact sensors, or moments where people would edit code without telling other people, and then or people didn't have the most up to date version of code. And it really creates a headache, so it's important to just stay on top of it.
Yeah.
Okay.
That's it. Yeah.
So speaking of like getting help, is there like a mentor that you feel like has helped you over like the years?
Oh, definitely.
Multiple.
Like every mentor nearly. I think all of our mentors are like really good. I remember when I was a freshman and I first joined the team, it was also Will who like taught me about like how to program teleop and auto for the demo boss. I remember it was Primus. Is it? Yeah, probably it was Primus, but never mind. And all of our mentors helped a lot. Yeah.
I've had a lot of help from many mentors. Will was one of them. One of our now graduated teammates, Graham Simmons, very helpful.
Yes, very helpful. And also Mr. Peach.
Mr. Peach is also very helpful as well in regards to what might be causing an issue. Our oldest coach, who isn't even a programming coach, Mr. Doan, is also helpful in regards to defining the difference between coding and programming.
Yes.
You can program something without touching a line of code. It's the program is the logical through line as to how things work.
Yes.
Coding is just what you have to do in order to get it down on your robot. Yeah, stuff like that. Very helpful in regards to brainstorming why things may not be working, or figuring out how to do things.
Yeah. And Mr. Simmons, I want to say.
And Mr. Simmons.
He's like really good at like guiding us through like the
testing
plannings.
regimen.
Yeah,
as well.
Plannings and our priority, and he always gives like really good reminders on what things need to be done and like what we're looking right now.
Pick your poison.
Describe what auto is, and then describe what teleop is.
Oh yeah, so auto specifically in an FTC game is the first 30 seconds of a 2.5 minute game, and in these 30 seconds the robot needed to complete tasks. Like this year we need to shoot balls into like baskets, automatically, which means we can't touch the controller. We can only hit start and it will run a pre-programmed sequence that to let the robot to complete all the tasks.
Teleop is the rest of the game period, which is generally another 2 minutes, and it's short for teleoperative. So that is when you actually have people driving your robot, and in that case, you need to program every part of the robot to be. You need to program how the robot is actually controlled by people, which seems straightforward as to, you press a button so that this thing goes to this position. However, a good teleop will kind of turn into an auto where it's a bunch of automated sequences that are triggered by different buttons. And in that case, you need to think about every possible situation that your robot might be in and have a manner of getting out of that situation into your desired one.
Okay, how much planning does it take before you actually touch the computer, like to start coding?
Yeah, so I think I don't know if this is true, but it usually takes me like one meeting, which is like about 2 hours, 2.5 hours to do the planning, because I do the auto strategy plan with the help of some coaches when the game is launched, and then we basically just plan out where I want the robot to go and what task I want the robot to complete during the 30 seconds of auto.
Yeah, the split's kind of weird. Generally, there's a lot of overlap between auto and teleop since you're working with the same robot. If you're programming effectively, 90% of your code is going to be overlapping between the two. So for auto, my understanding is it's pretty quick since they have a wheelbase that they can use to have the robot trajectories, which is how it's moving throughout the field. And they can start debugging that almost immediately. So it might take you only a minute to just draw up a graph as to how you want the robot to move around.
Yeah.
On the teleop end of it, it's, okay, I need to wait for an idea of the entire robot to be finished. And then once that's there, I need to then spend, maybe it's a meeting, maybe it's 2 or 3, planning out each individual subsystem that's like a little tiny section of the robot. I spend time planning those out. I think of what parts I have control over in each system. That's motors, servos, any sensors, stuff like that. And then I can start touching code in terms of defining those. And then I need to press pause and then spend time thinking through all the different possible cases and then possible automated sequences that I need. What does each subsystem need to be able to do? And once I have most of those planned, I can go back into actually writing code. And sometimes it's weird because sometimes I might just take a piece of paper and write code on that before I get onto the laptop to do it. Just to start to see a visualization of what things will look like.
Okay. For even, how many different auto situations do you need to like code this year?
What do you mean situations?
Like depending on where the bot, like what team it's on, like what color.
So yeah, this year's auto is really interesting. So it gives you how should I describe it? So there are 3 what is it called? The thing on the obelisk. 3 patterns?
Randomizations. I think there are motifs this year.
Yes.
Yeah.
There are 3 randomizations that are gonna be set randomly before every competition, which means we need to prepare at least like 3 starting positions. At least three methods to get the point. I don't really know how to explain it before the game is explained. But this year what we did is is we kind of like dissect the whole auto into actions. So we define like the bot moving from one point to another point as an actions, and then we wrote each of these actions separately so that we can combine any of the two actions or any of the 3, 4, or 5 actions together, which gives a big flexibility on your auto paths, and also gives your partner or your enemies, mainly give your partners convenience to plan their auto too.
Yeah. Okay, so when you're like driving the robot, what do you use to control it? Like in Teleop?
We use 2 controllers, like video game controllers. They used to be Logitech ones, but it's essentially a PlayStation controller, and you can use actual ones as well. I think we're using PS4 controllers right now. Some teams will also use an Xbox controller. Yeah, that's pretty much it. That entails a few analog inputs with your sticks and triggers, and then a bunch of buttons.
Okay. And do you always use completely new code like every year?
No.
Oh, not at all.
Nope. If I can reuse code, I will do that, because reusing code is an interesting thing. Sometimes you can get away with it and it's perfectly fine, but you need to be careful to make sure that it is applicable to the current challenge that you're trying to complete.
Yes.
I remember last year I reused some code that had issues, but worked fine for what it was meant for, but for what I was trying to use it for, it had some major issues.
Yeah.
But yeah, the benefit with reusing code is that it's something that you've written before and you presumably understand how it works already, which makes your development cycle pretty quick and fast forward. And sometimes different code kind of just looks similar year to year.
Yeah, there's also a lot of resources on the online, as Victor has said, like WPI Lib or like FTC Lib. We always like get like codes from there, and they usually have like good explanations on them, so we can like apply them to our bot to make it better.
There is more to robotics than just building and programming. The upcoming episode will be about outreach and documentation. Thank you for listening. See you next time. 5-3.
5, 6.